Let's go for the constants thingy first, I guess.
Yeah, we got Ollie here, this is the constant. What exactly are you proposing?
In the RFCs, no, that,
RFCs?
I think.
This?
Oh yeah, that one. But I think
I
like
think the first thing was the replace our fragile safety scheme.
that one.
This one.
Yeah. So okay. Yeah. So this was apparently discussed last week. So I think it's mostly implementation now. We just implement the rules as specified, and yeah, like from our end, it was mainly like how aggressive do we want to be with erroring?
Okay.
Does that make sense to you? Using the existing um, notion of what is live and dead code from ML.
Yeah, I'm not quite sure how we can figure this out, like how we can ask BorrowJack whether something is actually live.
No, you don't want to do that. I mean, you don't really need to ask BorrowCheck, I don't think. It's more that BorrowCheck runs on the mirror at a given point. I think it's mirror validated or whatever. And it does not, if you just sort of walk what's reachable by the edges that exist in the graph, that gives you a subset of the program that BorrowCheck considers reachable. It doesn't take into account things like if there's a branch on false that goes to two different blocks, both those blocks are live. Look at the value yet, right? And there's some later path that cuts out the true path.
Okay.
So you shouldn't have to ask BorrowCheck anything. This is all being done on Mir.
Yeah, of course. As like the problem we have right now is that even during generation of Mir, we are losing some constants if they are basically if they have the never type, the constant, then it doesn't actually end up in Mir build. So we had a fix for that, but that kind of regressed performance in other places. So it's like we basically don't really want to change any kind of Mir generation or anything. We just want to figure out which constants would have been generated and then report errors on those.
I see. Yeah, I remember being I feel like we discussed some of this when we were discussing, I don't remember exactly when this was, who was proposing what, but we were talking about changing mirror build to be more aggressive about not generating never related. Knowing, for example, that things that have never.
Okay.
And I mean, we pushed back exactly for this reason, to be careful around what kind of errors we get.
I mean, we can just say if there is any kind of constant anywhere that ends up evaluating to the never type, that is supposed to break the build.
We could say that.
Anywhere sounds well. So if you have panic and then you reference a constant which is of never type or some other like uninhabited type, or even a constant that has errors for some other reason, then that shouldn't be an error, I think, because that would not be reachable according to ML.
But the only reason constants aren't a hard error if they fail to evaluate is for backwards compatibility. And for the never type, we don't actually have to care about this.
Oh, I don't think we should. So wait, we're looking at.
Wait. Let's go one step back. So we used to have a run over the HIR that found all constants. And whenever they found a constant, it evaluated it. And if there was an error, we did a hard error and aborted. But some changes in the middle actually made this just lint to not cause backwards compatibility issues. And that is the only reason we are not hard erroring right now.
So even if the constant is used.
If the constant is used, it's a hard error always.
Right.
Because otherwise you have a broken constant, and going over, like using that at runtime is basically undefined behavior because we don't know what's happening. But we don't actually look at like constants that are like, in dead code. And the
Right.
HRR pass would still pick them up and at least lint on them or something. Yeah.
So I think the nub of the issue is, what does dead code mean? Because it could be the notion of dead code after doing constprop, or like.
No, that's exactly what we don't want.
Right. Right.
We
don't want optimizations to affect what compiles and doesn't.
Yes.
But that's exactly what. So if you use NLL's notion of dead code, then, for example,
I understand that the problem is we already have this problem at mere generation. That is where the entire issue was opened, because we were generating MIR. Well, that I don't even care about that part. Sure, we can just not error on that. That's fine. The part that I care about is if we have a constant of never type and we use that constant, the code just compiles and goes into undefined behavior immediately. And we fixed that, but that caused performance regressions.
So
because,
can you give me what's the example that was like, what's a good canonical example?
that one, yeah. But you don't even actually need the unsafe code below. You just literally need the constant part. So you can remove the unsafe block. The unsafe block is not relevant. Because we have the let underscore creates a variable of never type, and that is impossible to happen. Everything behind that is unreachable, thus compiling down to unreachable in LLVM, thus being undefined behavior.
Yes, okay. I can sort of understand how this came to be. And I guess what's missing here is that we didn't consider this an evaluation of the constant for the purpose.
We didn't consider this in mere building. Mere building actually skips building any kind of code around never types at some point.
Right.
Or used to. We fixed that, but that caused performance regressions. I think it's just build time regressions, but I'm not sure.
Okay, so the crucial difference between this example and the one below is that in the one below, the constant isn't what is causing divergence.
We can figure out the part below. I don't really care about that part. The part that I care about is collecting the constant foo in the upper example during or before mere building without doing the new mere building, which has performance regressions, and just doing the old one. Basically, we don't want foo to ever actually end up in MIR, but we want foo to somehow be registered as must be evaluated before this function is legally compiled.
Right.
How do you plan to fix that?
The plan to fix that is basically have something like the promoted vector in MIR. Just it's a constant vector. All the constants used in the MIR are listed in a vector, and we just go through that list in the end and evaluate all of them. So no matter what kind of optimizations happen and start removing them, the collector in the end will know all the constant that existed at build time, at mere building.
It seems like that feels.
I think that should work.
But how does that relate? I mean, I guess I'm wondering for Central's example, like that would be in the list, right?
That would be in the list, but it's very easy to write a mere pass that detects the situation, just removes it from the list.
How is that? Why is that so easy?
Because the way you described earlier to how we walk the MIR graph of the what is reachable, we walk that graph and we do like any constant we see in the MIR, but that we can't reach via this MIR crawling, is one that is in dead code.
Can't you not put it in vector instead of filtering?
But if we then we lose the constants that don't show up in the MIR at all because they were optimized out during mere building, or not optimized out, but like were like kind of ignored.
So here's what
I guess I don't understand why they were ignored.
Because the generation of this this lead binding is basically that in MIR building we skip the building of the entire lead binding because it has never type.
In building?
Yeah. I can show you. I can show you the PR. Like I can show you the fixed PR.
So Ali,
yeah,
you can show that, but I need to ask this question. So if you had code like this, right, where you wrote it by hand,
yeah,
and maybe this is assigned the type bang.
Yeah, that's right. Rather, that actually is built because the panic has all kinds of stuff that happened before.
So it goes up until some point, which causes the panic to occur.
Right? Yeah.
And then, so it seems like referencing a constant of type never.
That is the
also introduce something into the mirror before the panic actually occurs.
Right. That's what we do right now.
Going to trigger the validation.
That is exactly what we do right now. So I think Matthew Jasper wrote a PR that fixed this building. And the problem is it generates too much stuff around, like it generates more drop code and so on. And all of that costs like 2 to 3% performance regressions. I think it's just built-in regressions though.
What if I do something like...
Okay, I mean, I guess this meeting doesn't seem like the best place to dig into the implementation questions exactly. I mean, in terms of from what the user's external point of view, you know, we want this to be an error because the use of foo is live.
Mm-hmm.
It seems to me like the use of foo is live. Anything that follows the use of foo is dead.
Yeah.
Potentially, right. But the use of foo is live. And similarly here, we want this not to be an error because that constant is dead.
Yeah.
I don't actually have a super strong opinion about that. I could go for both of them being an error, except that I think there is like a backwards compatibility. First of all, I don't know. I could be persuaded either way, but I do think we have a backwards compatibility thing here, right? Where we have been accepting constants. Is that true? Today on, if I have a bad constant, do I accept it in this position?
Likely.
So what about, so is there any difference between foo2 and foo? So
that's another question I don't know the answer
to. Right. That is probably, yeah, that actually did not do the miscompilation.
But both should be an error, right?
Was an error, yeah, but only the never type constant did the miscompilation.
And this is not specific. Is it specific to never or uninhabited types?
Uninhabited in general, yeah.
Okay.
Because if you end up with a value of uninhabited type, that like, yeah.
Huh. I do not like that. I don't think we should be skipping. Well, I have to check, but there's also this notion of private uninhabitability. I forget if we do that right. I hope we do.
Yeah, we do.
I remember we did pay some attention to that, though, so probably we did.
Yeah.
Okay. There's not any uninhabited type. It's those that you know to be uninhabited, kind of.
Yep.
Okay.
All right, but it seems like so the general idea is that we should use the bar checker's idea of what is live and what isn't. And
yeah, we must. I just checked. Otherwise, we have a backwards compatibility issue.
Right. Well, let's see how complicated that is, I guess. And if it's like really bad, then maybe we should have some other idea.
Yeah, I think this is just an implementation question at this point, like figuring out if we can make this without a backwards compatibility change. The alternative is to keep the current system and try to optimize it so it doesn't have the 2% regression. But at the same time, the fragility wouldn't go away because any optimization could start optimizing out one of these. So if you were using the never type thing and if false, and it got optimized out, then we would not have an error anymore, even though that code, not by borrow check standards, but by constprop standards, would have had a never type constant.
I think whatever we do, it's important that mere optimizations can't have effect on what compiles and what doesn't, if you allow lint.
Mm-hmm. So mere optimizations should not suddenly cause errors to disappear.
Yes.
Exactly. Yeah. So I think this is an implementation question. I think we can figure this out.
Okay, yeah. But it's right. But it seems like you got like what you needed.
Yeah.
Cool.
Okay. So it seems like we're in agreement. Modulo implementation strategy, which I feel is not the best use of this moment.
Yeah.
Let's see. The usage of erroneous constants, that's the same thing, right?
But yeah, there's no real difference.
Okay. So I think we can remove language from this one and just leave it for the comparison.
In general, there was I'm just going to write it down. Conclusion. Uses of constants that are dead, that are unreachable according to NLL, or would not trigger errors even if their definitions, I don't know what, contain why exactly does this fall out? Because they're not verifiable or something, or we just don't allow?
Oh, no, if the constant has an error, like if evaluating the constant causes an error.
Okay.
Right.
Okay. Stupid thing. So this is because backwards compatibility.
Yeah.
Right. Very good. I just wanted it written out. Yes, so in particular, NLL's notion of reachability is not dependent on optimizations nor particular values, right? E.g.,
Yep.
if false X,
Yep.
X is reachable in if false X.
Yep.
Cool. I guess I can leave a comment again.
Okay.
Oh, well.
Great. What was the next Ollie topic?
The next Ollie topic, should we scroll up to constval again, maybe? To the shepherded items.
This?
Yeah. So the mutable references, they are nightly right now, but we never had an RFC about that. Seems like it might be a good idea to have one. What do you think?
Well, they basically were never discussed like as not being in constant or being in constant. So there's no RFC, but these kind of constant values basically predate any time that I have been at the Rust project. So it was basically just an implementation missing there.
You don't think there are any design questions?
like they're basically super safe because like in statics and so on, they're all immutable anyway. Like they are just in the type system, they exist, but you can't really use them as mutable. So we're having some discussion in the MirOpt working group right now for constants around this, but I guess we could do a small RFC. Just so everybody has seen all the sides, yeah. But like, we're basically hashing out the implementation details, and maybe we can do like a stabilization RFC that just gives the status quo a discussion, because it doesn't seem like there's many complex issues there, because the mutability will never be usable as mutable. Like
sorry, continue.
Oh, you will never have actually a mutable reference that you can use as a mutable reference. This is just in the type system for statics, constants, and so on. Mutable references inside a constant during the evaluation. We already have mutable variables. Mutable references don't add anything new.
Yeah, I think focusing on the implementation and then like designing after, like providing the spec after we've implemented everything.
No, like
makes a lot of sense.
We can definitely write a small RFC, but like it's from the concept perspective, it's mainly just like some implementation in the background.
Cool. Yeah.
We're mostly removing block.
Cool.
Internet connection.
We could.
Sorry. Yeah. So basically, we're just removing blockers, or like removing checks from the static checks on constants. We're not really doing more implementation work there.
So one perspective, one reason we could have an RFC is that by having mutable reference types and borrows or mutable reference types as inputs to const functions, you give up referential transparency.
Okay, let's do an RFC, because let's not talk about this right now, because we're just going to talk about it forever then. Yeah, okay. I don't, yeah, we all have our positions on referential transparency. I don't even understand the word properly, but let's just move it elsewhere. It's not productive time of this meeting, but yeah, let's do an RFC.
Okay.
So there's one third thing below, I guess, but the comment you just made raised to me a sort of meta question. We've been discussing how to sort of manage this const eval effort, right, and help everybody stay in sync. And I'll quote from Ecstatic Moors on Zulip recently writing, "I interpret my role as something like shepherd for control flow and constants, which is proceeding nicely, but beyond that, they don't feel like they have a good picture." And I know you're feeling pretty busy in general. I'm wondering, maybe if I feel like I would like to just know what the big picture is we're proceeding towards. And I think I do, but I still feel like somehow, like we've never made decisions about this. We never agreed on what unsafe means or so on, right? And I'm wondering, how concrete of an idea do you have? And as an immediate step, maybe like a one-time thing would be that we do try to have a meeting about just that, like what the overall plan is. And
yeah, I'm sure Ecstatic Morse would work together with me to write down a document, so we have like a starting point where we can all talk about. We had a recent discussion on Zulip, and it looks like at least we two are very in sync with the ideas and plans and what's going on. So yeah, we could.
Such a document would be kind of, I mean, even a bullet list to start of like.
So the tracking issue for const eval has a bunch of links and stuff.
You mean the const of n tracking issue?
Yeah, it's like a big one for everything. I think
that's not exhaustive. Let's make a special document.
Yeah, but I think heap allocation is one thing that will become a blocker soon, and we need to think about traits as well. But,
yeah, I think the traits are problematic first.
Yeah, traits are. Yeah, allocation and traits are the difficult parts, I think.
I mean, we don't really need a heap. We can just use stuff like small vector or like what's it called, array vec or something. People can emulate this. We don't really need a heap for now, but like the other parts are more important. But like we can make a document of the full big picture, like, and then have a meeting about it.
If you that would be amazing, and if you do like schedule some time to hack on such a document, or I don't know. I might be interested in being a fly in the wall, in short, if you're having a conversation on Zulip or something, but I may or may not need it. Don't block on me, but ping me.
Okay. We'll tell you when it happens.
So, so the recursion limit stuff, is there anything you think we...
Oh, we can just lift the recursion limit. There's no recursion happening during const eval. This is literally a vector of stack frames that is getting pushed. So if you do too much recursion, you'll just blow up your heap, and at some point your compiler will die. But we can just limit this with the normal recursion limit from the compiler. So we can just hook up the same value, and then people can adjust it.
But what about like loops and like infinite loops and looping too long and so on?
Yeah, but I mean, if we have a hard recursion limit, at some point, if you recurse too far, it'll just hit the limit.
But what about loops that do not recurse?
Right.
Oh, those have a step counter. They'll hit the step counter at some point, and you'll have to increase the limit. There's currently an unstable attribute for the const limit.
Did we land that one?
I think so. Maybe, I don't know. It's happening right now. Like basically, we have two things. We have a loop detector and we have a counter, but the loop detector isn't really working. So we are moving back to the counter. And at some point, you just have evaluated too long, and your compilation will abort. And you can increase the limit if you want to run your compilation longer.
Right. And the RFC said something about the number of terminators. Or
well, like, terminator counter, yeah.
Yeah. I think that makes sense instead of instructions.
No, definitely. The thing is, it's even post optimization. So if you run in release mode, you might actually get further than if you run in debug mode.
Yeah.
Well,
these limits are sort of, they don't actually exist in the language definition. So it's like...
Yeah, I guess we'll run with it for now. It's no worse than some of the other limits.
Yeah. It's the drawback of having Turing complete stuff.
Oh no. Whoever came up with Turing completeness.
Did we want to talk about the nominated RFC?
Probably, yeah.
What's there to say? Okay, so calling methods on generic parameters of const fns.
Yes.
So actually, I will print out this RFC after the meeting and read it after dinner. But so there were some questions around drop and stuff. Yes. I think they're probably changed several times, even.
Yeah, we had an original design. Then people were like, "Why can't we reuse the existing drop?" So we moved to that. But apparently, people are really doing bad things with drop bounds on generic functions. So we can't do that because we'll break backwards compatibility on one crate on CrateSale. We're basically thinking about moving back to the original proposal, which is kind of having like a const drop trait or some other sort of modifier. We can adjust the syntax later, but just so we have some scheme to work with this.
So my basic feeling is that this is such a big change to the language that you sort of have to be experimental about it, and like armchair design won't work in this case. Sort of have to try it out and see what makes sense and what doesn't, and what actually works in practice. And so like we can see, even with the drop stuff, we can try something out, see how much we can how many things we can quantify, see if we have any problems, and maybe change the design based on that.
Yeah. Nico, you can't load that issue because that comment because it's in the middle of the unexpanded ones, and yeah,
it's fine. I'm like trying to remember. Apparently, I checked my box, but I have like 0.
No, you didn't.
Oh, okay. Well, this seems like a great example of the kind of, I don't know. This seems like, I agree with Central that this is a pretty big, if I'm understanding what's happening, which I'm only having read this little thing that's on my screen right now.
Yeah.
I think what's happening is there's a sort of implicit mode happening here.
Yeah.
So to speak. This is a constant impl.
Yeah.
It's a fixed polymorphism, more or less.
Right, and that requires that the impl has const fn on all of its something. I feel like this was worth. Yeah, I mean, I think that's probably the right design. I do think this is a big change. We're gonna have to think about that, exactly how that propagates through. Like Chalk probably wants to model that, for example.
Right.
But,
so this has basically been open for over a year because we've previously been working on this in the Constable repository.
Yep.
And Vicor and lots of other people have like put thoughts in there, and we've broken and unbroken the design a few times.
Yeah, I don't doubt it.
I don't think we can actually progress without having implementation to test.
I think that's fine. I think what I'm saying is this is a great example of the kind of thing where I would love to say, let's approve that we're making a project group with this as the direction to explore, and we will get feedback from that and some updates. But I think it would be even, I would love to have a meeting where we just go over this and talk about it for an hour, just so we all actually understand it.
Oh, we can do that. Definitely.
I mean, both probably, but.
Yeah. Do we need another project group, or can't we just like tuck it into the Constellar?
This kind of
I think it's the same group.
Right. All right. Yeah. Sure. The one part of the RFC I would like to remain as is the syntax, not writing constable.
Yeah, but like we can figure this out at stabilization if we want to. That's bike shedding on syntax.
In terms, I mean, you can use an attribute rust underscore or whatever for now.
Yeah.
All right. In favor of doing this experimentation. Probably this.
So do we do another meeting in January where we just meet about this one, or do we try to just get it moving as an ERFC and do the meeting anyway, but like keep this moving?
I think
so. Could we say the following? Even with the RFC unlanded, we can like start experimenting with this stuff.
That's fine. That's fine with me.
What do you think, Nico and Josh?
I feel okay about it as long as we know who's going to review it, which I think we do, because it's probably you, Ollie.
Yeah, so Ecstatic Morse actually was very positive about starting to experiment on one of these topics. So maybe they're interested in just doing this one for now.
Oh,
Yeah,
I
and I
thought.
guess this is going to take some type system support too.
A little bit.
It's not too bad, but
yeah, I think we have most of the things there. I think it's mostly well-formedness checks somewhere.
Are we reasonably confident that this will interact well with future const generics in terms of?
Yes,
Okay.
we specifically were thinking about how this works with other parts of the system and future extensions. Some of them I listed in the future work and other sections later in the RFC, but especially const generics actually are completely orthogonal to this one.
Okay. The specific context I'm asking in would be things like in the Safe Transmute working group, we're currently staring at how do we figure out size and alignment of existing types and embed that into the type system to the point that we can make type system level decisions of we'll be able to cast this to this with sufficient alignment and have all of it fall out. So we ran into issues that amounted to this RFC as well as issues with const generics. So that's why I wanted to ask.
Mm-hmm.
So
Okay.
I would just like to mention that like this is not an RFC that will actually will be stabilized anytime soon. I think this
Neither will const
require.
generics at this rate.
Yeah, sure. Yeah, I'm just thinking about like if you need this very soon for stabilizing something.
No, we're not expecting Safe Transmute to stabilize soon. We want to design the right design long term.
Right. Yeah.
So one thing that we might be able to stabilize soonish from this is the question mark const, because this is actually how how trade bounds and const defense work on nightly right now. If you enable the const defense feature gate, the question mark const is basically you can specify the trade bound, but you can't use it.
That is roughly what we ran into, was that we specified the bound of sized and we weren't allowed to use things that depended on sized.
Correct.
So this would solve that problem.
Wait, the size bound should be allowed. Didn't we?
The size bound is allowed, but you can't do anything with it.
You can't call size underscore of in const fn and assume that you can on a generic type.
Oh, hold up on there. Like we can talk about this later, but I think that should work now. I don't know when you tried this, but this should work now.
We have a specific bug that we evaluated. I can send you the details offline.
Yeah, let's do that.
Can you send it to me as well? I think that might have
Central,
to be
you already got it. It's the one that Ryan sent, and you said, yes, report a bug in the future.
Oh, that one.
And the same one that Nico, you said, actually, we might already know that one.
I think that has to do with lazy normalization or something.
Oh, that okay. Then it's orthogonal to the RFC also.
Yeah.
Okay, that's interesting.
So we have 14 minutes left. I'm not sure exactly what we should do now. But I think we sort of, at least the four of us here, sort of feel like we can continue with something on nightly, even with the RC. I'm not sure.
I think that's right. I think, Ali, you should consider that it seems likely that we're like, yes, we will want to do this, but we should also be planning to have another meeting. I will try to follow up with you on that. I think we now settled on a time that seems to actually work for most people in the Lang team, which works for other people, but if not, we'll pick a different time if it doesn't.
Yeah, no, I can come on some other Thursdays, just not like generally.
Okay.
The time specifically would be 17 p.m. or 16 p.m. on Monday.
Oh, that would be even better. Like, yeah, then I can come.
Yeah, because I want to make a second slot for like longer discussions.
Sorry?
This is the one that would be 9 a.m. Monday, U.S. Pacific?
Yes, that's the 9 a.m. or 8 a.m. depending how.
Yes, I'll happily take the 9 a.m. Thank you.
Could you comment, or could somebody from Lang team in generally comment that the Lang team is like all right with some nightly experimentation of this RFC, just so we have like this noted down somewhere?
Nico, want to do it?
I'll do that.
Thank you.
Also, regarding your earlier comments about timing, what is our plan for meetings for next week and the week after? Because I'm kind of assuming that, for instance, January 2nd, we might well have a Thursday meeting, but the day after Christmas doesn't seem too likely.
Yeah, I was assuming I won't be available the next 2 weeks.
Is Christmas the 25th or the 24th?
Christmas is the 25th, and I won't be available.
No, it isn't. It's the 24th.
Give me this nonsense. Whatever. December 26th, I'm not available.
For example, I'm assuming that Monday, the meeting we talked about for Monday, wouldn't happen until January?
That's correct.
Okay. So
that wouldn't be until January 6th.
Okay. January 2nd is probably the next time the Lang team will see each other?
I think that's right. I was going to cancel the December 26th meeting. I think it's
probably a good idea to write this in a more permanent location.
I mean, I'm just going to delete the calendar events.
That works for me.
That's my canonical signal.
Yeah, that works for me. Let's see, we have 10 minutes
number
left.
Of this RFC, darn it. I almost finished this comment before I lost track of it.
2632.
Okay, I'll try to do this. I'll do this today.
Is there anything specific we would like to discuss here?
The final time we have here, skimming here. Erroneous constants, structural match, no. I think this mem zeroed, we could probably wait, but we could also discuss a little bit briefly what we want. Well, let's talk about the partial EQ for range inclusive.
Actually, if I could make a quick comment on the mem zeroed, mem uninit item for zero initialization.
Sure,
just that the type classes that would be needed for those are closely related to the type classes that we need to define for things like safe transmute. So it might be a good idea to pull Ryan into that discussion, because the concept of like, this is safe to initialize from raw bytes is vaguely related to this is safe to initialize from raw 0 bytes.
Wait,
that's a good point.
This is purely dynamic semantics. It doesn't have anything to do with the static semantics.
I understand that, but what we're talking about defining is effectively how do you recursively evaluate a struct or similar to say that all of its types can be 0 initialized, and therefore it can be 0 initialized, just like all of its types are capable of being converted to from bytes, so it can.
Okay,
the concept of recursing over structs is kind of related.
So it would be specifically the type, the set of types for which instantiating the type parameter T4 zeroed would never panic.
Wow.
Would be legal, yes.
I mean, I think what Josh is saying is if it can be initialized from arbitrary bits, it can surely be initialized from 0. But it should be clear that there are also types.
It's a sufficient but not necessary condition, yeah.
Right.
Can I throw something in? In Constable, we have a check that checks if a binary representation is a valid value of a specific type. So if you generate a constant that is just all zeros or all undefined and then give it a type, it will tell you if that's okay or not.
If you have a mechanism for that and we can wire that into the trait system, that sounds great.
But this is sort of what, so kind of what Ralph's doing here, right? Presumably Ralph knows about this, I'm pretty sure.
Yeah,
I think they wrote that mechanism or something. Or they were at least
involved
in it.
So to say this a slightly different way, doing this in dynamic semantics makes perfect sense. I would like us to have a plan that leads toward, in the future, we could use mem zeroed and take the result and safe transmute it to a type and know statically at compile time that we were allowed to do that without having to handle any runtime errors because we happen to know the type allows this.
Mm-hmm.
So short term, we could make this dynamic semantics as a cross-check of you did something wrong. long term, I'd like to have that reflected into the trait system so that there is a trait level property of a type that you can zero initialize.
I don't think that could ever be automatic. That always needs user decisions.
You might, so to clarify, you might still have to opt in by deriving the trait.
Yes.
But it would be nice if the compiler can tell you, are you allowed to derive the trait?
Mm-hmm.
The same way the compiler can tell you, are you allowed to derive the trait that says you have no padding so you can transmute to bytes without UB?
Right. So what the compiler would check is that you uphold the validity invariance, but you still need to opt in for the safety invariance because there might be like user-defined invariance, whatever.
There might also be the fact that what if you're a marker type and you're not supposed to be constructible? All sorts of fun, yeah.
Yeah, that's what I meant by
that makes sense. I just want to add I want to posit something here. So what we said before, which is a little different than what we've been talking about, but just to give feedback to Ralph, what we said before was we kind of want to have the big picture, and Central, before the meeting, Central mentioned to me, and I agree with this, we'd like to sort of check off on the mission and then not have to check off on all the steps necessarily, because kind of every time we like forget what the context is and we get confused and things like that.
Yeah, and, I think we should check off on the mission of go implement the dynamic semantics and just have a comment that says, we'd like to make this possible to do with static semantics within the type system in the future. Please correlate that with safe transmute.
Yeah,
that's all I'm asking.
I agree with that, but what I'm wanting to ask is this checkoff on the mission. Like, in some sense, the mission is defined, although I don't know how we or when we sort of decided it, that things that can't be represented as, you know, all zeros will panic. But that maybe begs the question of what are the things that can't be represented as all zeros, and how was that decided, and where, and so on. And so how detailed do we feel we need to check off, and what are the decisions we think we want to make is what I wanted us to add.
So I think I would like to see like not super long design document that states what the mission is, so that everyone agrees on what it is. But if we decide that the validity to relax the validity invariance and like change the operational semantics, so that then we could also relax the cases where it panics in the future.
Okay, so that's two different things. That's a good point. So there's some considerations. One is like, would we leave room to remove panics in the future if we relax the semantics? And the other question was like, how are we going to say which types it's valid for? I want to put forward that I think it's probably a better idea to have a place where we're collecting the design, agreement on the overall mission of making it panic, and as you said on that, I think we could write up some of the considerations, and then look at the cases as they come that are controversial, versus trying to know everything up front, what are all the types we will ever do, and so on. But I think we should be collecting what's the picture, and there's like a couple of states in this picture, right? These seem like we've agreed these are acceptable, we've agreed these are not, and we think these should panic, but they don't yet, and we don't quite know about that or something. If we had some kind of document, especially one that was kept up to date, that was showing that, that would be awesome. And maybe that's something we can work with Ralph to create.
And so the initial document is like something I would like to FCP as well.
Yeah, I agree. We should FCP the mission, sort of.
Yeah.
Did we ever decide this in an RFC?
It's not importing, right? It's just the normal path.
Sorry, panic. You're correct. But there's not been an RFC that said we should do this panicking, or Heather has. Maybe that was part of some.
No, I think it's like taking inspiration from the panic if uninhabited thing that we already have, that we introduced when we stabilized mem maybe on
yeah, that's what I was wondering, if we actually said this in the maybe on init RFC. But
I don't think we did, but it's like this is something that came up when we tried to make mem uninitialized and mem0 use maybe uninitialized, and it sort of changed some aspects of cogen in some ways. And then Ralph added a lint, and then he had the idea that we should also like change the dynamic semantics for these functions to safeguard some more.
okay.
But it's based on inspiration from panicking on habitat types.
I think, yeah, okay. This is an interesting case of, in some sense, I want, like, it doesn't, I don't know. It's a thing that we're doing, and I've been trying to say I want to reify those into project groups. I'm not sure that needed here, but I would love to have at least on a list of, it's a project, even if it's one that's moving very slow, right?
Right.
And I would love to be describing it and capturing it somewhere.
I think a project group is probably more overhead. Like it says just setting up the bureaucracy feels like as much work as the implementation itself.
I agree. I don't feel the need for a full, like, maybe it's part of some other.
Yeah, I mean,
unsafe.
I think I would be happy to say, go work on this RFC, and also please join us in the Safe Transmute project. That would be fine.
Probably
just need the tracking issue.
Yeah.
I was bringing it up in part because I think I want to be able to talk about all the things that we're doing, and I want this on that list, but I don't want to put it, I don't think it quite fits that model. It's like a slightly different thing.
I think a tracking issue is enough, probably. And something in the unsafe guidelines as well, maybe.
The problem with just the tracking issue, we should end the meeting, and I kind of agree, but my only concern is that it's the kind of thing that could easily get, like, thankfully Ralph is pretty good, but it could easily get partway through. We do it for some things, we have some ideas of where it should go, and then somebody gets busy and Ralph has to go finish his PhD and can't get back to it for a while, and we just kind of forgot about it. And maybe that's fine, but if it's on some list of like stuff we're pushing, maybe we then figure out and decide. Anyway.
Didn't we decide Ralph shouldn't finish his PhD?
I'm happy with the way things are. I think he should. All right. All right. Thanks, everybody. Thanks, Ollie.
Thanks.
And happy holidays. No meeting next week.
Happy holidays.